Okay, so we are going to, I feel like we need like special music for this. The mean value. And I just passed back all your assignments that I have. Some of you have stuff missing. And so I'm going to email you and let you know which one is missing because I've documented which date it was so that you can catch up. The one that I found missing on a lot of yours, I didn't think it was because some of your entrance section was one where you had this like the student comes back and says, well, I just switched the there exists with a for every. So why does that matter? So that was one of them. The other one I actually wanted to talk to you guys about was the one and the epsilon delta ones where you did a Excel. That's one of the best in-class assignments because you can visualize what convergence really means from those, like actually see it on like, hey, as my x is supposed to see, my epsilon changes, my delta changes. You could see a lot of things. But I asked you to connect the analytical work back to the numerical work, and you left some of you left that part off. That was an important question. When you want someone to learn the analytical stuff and make sense out of it, you want to connect it to the numerical part. If you're not taking notes on your computer, please close them. Just some of you might go and want to come back and teach here. So, or you might go into teaching somewhere else. Just that math part, you never know. The two that came back from my Jedi math class were not the two I would have picked out as, hey, those two are going to come back one day. And you never know who's going to come back. Or you might go and teach somebody else, or somebody might find out, hey, you're good at math, help my 12-year-old with math. You have to connect those two things, the numerical and the analytical. So in courses that we take that are like 7th grade and above, we focus on the computation. And the connection's never made back to the numbers. So the number part that you did in Excel, that was really important. That showed you like why these, I can actually see the deltas dependent on that epsilon. I can see how these things are connected. I think it was an N maybe. I don't remember the problem that I gave you. But the next part actually had you crank through this, find the delta using algebra. And it was like yucky work. You had to complete the square and use the quadratic formula. You came up with a delta. And now I asked you to go back and say, did it match up to what you did upstairs for the first two problems that I gave you? That's an important piece because that's going to connect that piece back up. That's one thing. The other thing I asked you is, can you come up with a definition of the limit as x approaches c f of x equals infinity? That one. And a lot of you put things that were not correct on there. And I told you it was hard. It's really hard to come up with this. But the way you come up with your own definitions, which Carl has actually done that pure math project. That's what you do. You come up with your own definition of what you mean, and it has to encompass every possible scenario. So if you think of something converging to infinity as x approaches c, here's c, you'd want the only way that can happen is if you have an asymptote right there. And so you want something like this to happen. Right? So as you get closer and closer to C, it's going to go higher and higher. So that's the first draw picture to make sure you understand that. And then it cannot, could it wiggle? It could. But then if it's wiggling and coming back down, it's not converging to infinity. Right? So it has to do this in some way or other. So what I would think is something like this would work. For every bar that I make, like this, capital N, natural number, there's going to be there's got to be a little neighborhood around C where the function itself is over that bar. So I think when I graded yours, Sebastian, I was way too tired. I was like, I know it's got to be something like this. But some of yours, I put this definition. And I made it seem really easy just now by drawing that picture and doing it. But like I said, when I was grading his, I didn't have it in my head. So I had to think about how would I formalize that and make it a golden definition that will satisfy every possible scenario of what I mean by something converging to plus infinity. Some of you had plus infinity as a number, treating it as a number. Can't do that. Because infinity is not a number, it's a concept. One of the first things I taught my kids how to say. I abused my kids. The back of the car. Infinity is not a number. It's a concept. My son took foundations from me. And I was telling the students about it, what we used to do at home. And they looked over at him, and everybody was looking at him so sad, with these sad faces. And I told my son later, I could have told them I was giving you crack cocaine every single day, and they wouldn't have looked at you like that. They felt sorry for you.